So Anand, which chapter is coming in your exams?
Sir, motion chapter.
ठीक है. So, acha, the questions that I have seen in your assignments were of good level. So, do you have the PDF of those of that assignment, Anand?
Yes, sir, I do have.
Okay, okay. And okay, so like apart from the questions that I will give, also solve the questions from NCERT along with the assignment that is given by your teacher. Okay, because
So
the
I have already done NCRT and the assignment booklet, and the questions I could not solve, I just asked during the press class.
yeah, that's good. Yeah, that is because there are higher chances that teacher will give the questions from the assignment itself, and I will provide some of the questions to you so that these will be the hot type question, higher order thinking questions. And so once you are done with those parts, so you can solve them as well. Okay.
Yes, sir. Thank you
Yeah.
so much.
Welcome, dear. Welcome. Okay, so everyone, I'm going to share my screen. Everyone, please switch on your camera, bacho. Bacho, I won't be able to on my camera for today's class. So sorry for that. So, but I request to all of you to switch on your camera so that I can see your expressions and faces. Acha, one more thing. After this class, now I will be conducting one more class for the remaining derivation portion. Okay, for the equations of motion. So everyone, those who have the thing in the syllabus or those who want to stay in the class can stay. Okay. Okay, that portion will be covered, the derivation part by the algebraic method. Okay. Okay, please say yes or no.
Yes, sir.
Okay. So do please let me know who have the derivation portion in the syllabus. Anam don't have, I think so. Anam, you have?
Yes, sir.
You have derivation portion, both?
Yes, sir, both.
So what is there in the graphical derivation part, dear?
No, sir, I could not attend.
Acha, theek hai. So you can watch out the recordings for that because recording, like we have done the recording. Okay. So if you found any doubt in the derivation part, I will help you out. Okay. Hanan, do you have this thing in your syllabus?
I don't think so.
You are not confirmed yet. So ask from a teacher, dear. Okay.
Yes, I will ask.
So that like I've already like requested to all of you to at least like to get informed me about your syllabus. So if you're not confirmed, so what would you like to like? Would you like to stay or will you leave the class?
I will stay.
Yeah, stay. Okay, ठीक है.
It's vacation, so I'm not sure.
ठीक है. So चलो कोई बात नहीं. Only one class is there. If this is like if that part is there in your syllabus, so that would be well and good because you have attended the live class. And if not, because only one class is enough for that derivation portion. So like this will be the last class for that because one class for the graphical portion and the second class for the algebraic portion. So if you would stay, so that would be better for you. Sada, I think so. You don't have this thing, right?
Yes, sir, I don't have.
Check, check. Okay, Samia, what about you?
Sir, I also don't have.
You have?
No, sir.
Actually, you don't have. ठीक है. Okay, so let me check with us. Okay, so let's start the class, bachcho, without any delay. So, okay, so in the last class, we've started this the balanced and unbalanced forces. Now we are going to start. So this is all about the balanced and unbalanced forces. Actually, before that, starting the portion, let's discuss some of the questions of unbalanced forces. Uh, okay, just allow me a second. Bachcho. So, how are your vacations going on, Macho?
So vacations are already over.
Already over?
Yes, sir.
Sure, that's good. It means that it's time to study hard. Everyone, please switch on your camera. Samia, Hanan, Sara, and Saad. Just a moment here. अच्छा, योर स्टार्ट्स टुमारो, ठीक है सर। So these are the types of question or the like you can say that you will expect. Okay. Please do this one and let me know. Hello, Assalamu alaikum, dear. How are you? Arham, am I audible, dear?
Yes, sir, you're audible.
How are you?
Alhamdulillah. Very
I'm good, dear, as well.
good, dear, as well.
Please do these questions that I've given on the screen. Let me know the answer. Any answer? Let me know in the chat, Bichu. Arham, Samia, Sara, Anam, Hanan, Saad. Okay, I got the first answer by Arham. Okay, Samia. What about you, Anam, Sara, Hanan, Saad?
Yes, sir. I'm just sending you the answer.
Okay. Okay. Okay, Saad. Okay, Anam. Okay, Sara, you are only left, and Hanan. Okay, let me tell you so. Okay, these are like this is a very simple question. When a rubber balloon held between the hand is pressed, its shape changes. This happens because देखो, when the balloon is between our hands. Sorry, I got one more answer. Hanan. Okay, Hanan. So when the balloon is between your hands, so basically your hands apply the force in opposite directions, right? So it means that the forces that you will apply will be balanced forces. Okay, the option A is correct one. Clear, Bacho? Because I've already written here. If the just a moment, balanced forces produce here. they can change the shape and size of the body. Balance forces cannot produce motion, but instead of that, they basically change the shaping of the body. Okay? Clear? When we held a rubber balloon between our hands and when we press it, so basically its shape changes due to the balance forces acting on the balloon. Clear, bacho? Okay? First
Yes,
option
sir.
is okay. Which of the following effect cannot produce by an motion by an imbalanced force acting on a body? Change in speed, change in direction, change in. So which one? So let me check those who you have answered. Okay, let me check. Arham said A. Samya said D. Anam said B. Saad said D. Anand said D. So most of the answer questions like students are saying D. Okay, let me tell you the answer is B. Okay. So effect made by the unbalanced forces cannot change the shape of a body. Okay. Clear, Vichu? Because the change in the shape is caused by the balanced forces. Okay. When an unbalanced force is acting on a body, it will basically do what? It will stop the body or it will move the body. Okay. Two options are there because unbalanced forces means one of the force is greater than the other one, right? Okay. Okay, that's great. Okay, so these are the two questions. Now we are starting the laws of motion. This is one of the most important topic with you. Okay. Laws of motion. So okay. So as you know that that motion is basically, so laws of motion are given by the Newton, Sir Isaac Newton. Okay. So there are three laws. So we'll study each law in detail. Okay. So the first law given by the Newton is called law of inertia. Okay. So it's called law of inertia. So in this law, we basically do what? We basically understand the state of a body. Okay. So in this thing, basically we do what? Observe. So suppose that if a body is there and it is not moving at all, it is basically in the rest. So if it's in rest, so it means that if I don't, you can say apply some external force on the body, it will not going to start motion unless and until there is an external force on that body. Clear? Say yes or
Yes,
no.
sir.
Okay. So a body at rest. So this is the basic law of motion. It means that if a body at rest will remain at rest unless and until an external force is applied on that body. Okay. Unbalanced. Basically, the force should be unbalanced. Okay. Another thing is that if a body is in motion, so it cannot basically stop without any external agent. It means that you have to apply some external force to the body to basically move, to basically stop a moving body. Clear? So this is the
Yes.
first law of motion given by the Newton, that is called law of inertia. Okay. So, so let's take an example. Suppose this is a bus. Sorry, Vacho. Just there was some emergency. Okay. Okay. So what we were saying. So suppose that if suppose you are sitting in a bus. Suppose you are sitting in a bus. Okay. Okay, like this. These are the persons sitting right in a row. Like this, and this body is going like this. Okay. So suppose that if you're sitting and this bus is moving with some velocity velocity V. Okay. So if this driver suddenly applies the brake, what will happen? Can anybody tell me? What will happen? Anyone? If you're sitting in a bus and the bus is moving and the driver suddenly applies the brake, what will happen? Have you ever observed this thing, Vichu?
We will move forward.
Okay, we will move forward. Okay, one answer by Sarah. Is this Sarah? Or Hanan?
Hanan.
Okay, Anand. Okay. What about rest of you, Vichu? Samya, Anam?
We will experience a sudden jerk.
Speaks. Okay, Anam. Sudden jerk. In which direction, Anam? There should be a direction of that jerk.
Yes, sir.
In which direction you would like to say? Hello? Samya?
I'm
Sarah?
not sure about the
अच्छा।
direction.
ठीक है, चलो ठीक है अनम, कोई बात नहीं, नो वरीज। सारा आप बताओ।
Sir, everyone will come in the forward direction.
Okay, okay. Samya, Saad, Hanan, Arham. अच्छा, Hanan already said the answer. Arham?
So we will be pulled, forcefully pulled towards the driver.
Towards the driver. It means it's in the forward direction you are saying.
Yes.
चलो ठीक है, कोई बात नहीं। So what about rest of Saad? What do you think? चलो कोई बात नहीं। Okay, so those who have answered the question, so that would be okay. Achha, I got the answer in the chat by Saad. Okay, yeah. So what will happen is that, so if you're basically sitting in a bus, it means that your body is moving with the same velocity as that of bus. Say yes or no. Yeah. So
Yes, sir.
basically it means that when there is a sudden apply of the brake, so what would happen is that your body is in motion. So and the driver applies the brake. It means that there is a sudden action, or basically change in state of, you can say change in state of your body. So the body appears to be in the motion, but due to this brakes, what will happen is that the bus stops and suddenly you will go in the forward direction as the body wants to move. This is the resist of the body. Inertia is the property of the body that resists the change of its state. Okay? It means that if I'm sitting here, I won't be able to move unless and until I overcome my resistance of my body, or it means that my inertia of the body. Okay? So if we want to change the state of the motion of change the state of a body, it means that we have to overcome the inertia. Clear? And it is the resistance. Okay? So it is basically a property of a body that is basically to resist the motion, or you can say change basically in specific words. Okay, let me write it out down here.
Sir, then can we say inertia is the property that helps us to maintain a state of motion?
Not state of motion. It also helps us to basically, you can say state like in the state of rest. Inertia is there if I'm able to sit properly and stably. This is also due to the inertia, dear. If there won't be if there is no inertia, I will not be stable like I am right now. Okay, so if the body is in rest, it will remain in rest unless and until your body is not moving, unless and until the body wants change. Okay, there is an external force on the body, and same goes with the motion as well. If the body is in motion, it will remain in motion unless and until there is some external force on that body. Clear?
Yes, sir.
Okay. Okay. So a body. So before that, let me write down the inertia thing. What do you mean by inertia? inertia is that property of a body due to which it will resist a change in state of rest or of uniform motion. Uniform motion means the body is basically going with a constant velocity. Okay. If the body has some acceleration, it means that it already has some force on it because it's accelerating. It is changing the speed continuously. Clear? So it should be uniform. Clear, anyone? Okay. So if we talk about the inertia, some characteristics of inertia, the heavier the body, the more the inertia will be. Okay? It means that heavier body will have high inertia, more inertia than a lighter object. Clear? It means that if a truck is standing, so is it possible to move that truck with 2 persons? No. At least 10 persons are required to basically you can say change the position by inch, by a single inch, because truck is a very heavier object. It's very you can say bigger object, right, having great mass. But if you want to basically displace a car from its position, only 2 persons, even single person is enough to displace a car. Say yes or no? It means that heavier the mass of the body, heavier the size of the body, the more it will be its inertia. Okay, the more it will resist. Okay, so it means, okay, so heavier objects have more inertia than lighter objects. Okay. Okay, clear everyone? And one of the most important thing is that mass is a measure of the inertia of a body. It means that inertia of the body is the measure of mass. Okay. It means that we can measure how much inertia will it possess. Okay. Clear everyone? Please let me know, at least say yes or no.
Yes, sir.
Anyone? Yes or no, you can say. Mass is directly proportional to inertia. More the mass, more will be its inertia. That's what I'm saying. Heavier objects have higher mass, at higher inertia. Okay. Clear?
Yes, sir.
Sure,
Yes,
that's good. That's good. That's good. So if we talk about the law of inertia, so law of inertia says that a body at rest will remain at rest and body in motion. Will continue in motion in a straight line. Okay. In a straight line with uniform speed unless it is compelled by an external force. Force change its state rest uniform motion. Clear? Clear, everyone? Please let me know if it's clear to you, Vacho.
Yes, sir.
Okay.
Yes, sir.
Okay, so I've already told you that to overcome the inertia, to basically, if we want to basically move a body from rest, so we must apply some external force greater than the inertia. Clear? It means that if you want to overcome, so the force should be greater. Clear? At least say yes or
Yes,
no. Okay, sure, that's good. Okay, so basically this is a one conceptual question in this thing. So basically what will happen if we basically beat you can say hanging carpet with a stick? So what will happen to the dust particles basically residing in it? What will happen? Do you have any idea, Bacho? So let me tell you. So basically when you start beating a hanging carpet now with a stick, the dust particle will start coming out of it. It means that when you basically strike with the sticks, the change of the state of the particles basically allows them to move, right? So they were at rest when the carpet was hanging, but when you start beating the carpet with a stick, okay? So what would happen is that the change is basically there is an occurrence of the change of the state and the particles start moving. That's why they're coming out of it, okay? Say yes or no at least, Bacho.
Yes, sir.
Okay. And so basically when a car or a bus starts, so you must have observed that suddenly there is a push in the backward direction. When the car starts, it goes forward, there is a push in the backward direction. It is due to the inertia, because car was at rest, you were at rest. And when the car suddenly starts, the body remains to be in rest, but so that's why it is in the backward direction. If the car is moving, so inertia will go in the backward direction to cancel the state. There is a change, okay, to resist the change, okay? Say yes or no. And when the
Yes, sir.
when the running bus or car is stopping suddenly, so the passengers are jerked forward due to the change of state. Clear, bacho?
Yes, sir.
Okay. So this is the first case, basically, that we observe in the you can say inertia. And one more thing, bacho, that suppose this is a circle, suppose like this thing. So this is a circular path. Your bus is moving here. This is the bus is moving like this. Okay. So what will happen when there is a curve or when there's a turn? When the bus is moving right out the turn? Please let me. What will happen? So basically, you will experience a force in the outward direction, this in which the car is turning or the bus is turning, right? Because the car is going in this direction, so there is a change in the state. So inertia will cancel the change in this state so that you can remain stable. Clear?
Yes, sir.
Okay. So okay. So these are the some examples. So let me write it here because I've given already. Let me write it here. So these are the basically due to the change in inertia. Okay. So I'm writing it here. So first would be okay. So hanging carpet is beaten with a stick. So this first law of motion is very theoretical. No numerical is there. Okay. Only theory is there. Okay. So when the dust particle starts coming out of it, due to change of its state. Clear? Second is
sir.
okay. Second is when a car or bus suddenly starts, there is a push in the backward direction. When a car or a bus starts, suddenly the passenger fall backward okay, due to the change in change of state of body. Change of state is enough. Okay. If you talk about similarly, when the bus suddenly stops, are jerked forward change of state. Clear?
Yes, sir.
Okay.
Yes, sir.
And when a bus or a car take turns, sharply, we tend to fall sidewards. Okay, so it includes both right and left. Okay. Okay. Acha, one more thing I would like to ask. So you must have seen that when we basically when we basically traveling. So if I try to move, basically, you can say deboard the running car or the bus. So what would happen? Can anyone tell me?
Sir, can you repeat?
I'm asking if I wanted to deboard from a train or a bus that is moving already. Deboard means I just wanted to jump out of it. Okay, like suppose I'm standing at the gate of that bus, it's already moving. I just wanted to basically jump out on the road. So what will happen to me?
You will fall
I will fall. Okay. Why would I fall?
because your body will think that you are moving.
Your body.
Sir, we may fall down because earlier we were in a state of rest, but when we jump out, we suddenly get in motion. Maybe that's why.
Yes, that is the correct reason. Ha. Yes, Sad, you are also right. The reason is that behind, basically, if the bus is already moving, you have the same velocity as that of bus, right? But when you suddenly stops, when you basically jump out of that bus or a car on the road, so what happens is that suddenly, without any change of a second, your body speed is zero, becomes to zero, right? So, so basically, your body tends to move as with same velocity as that of the bus, right? But due to the change of your state, so what will happen? So you will fall from that bus. Okay. But if you want to basically counter this, what you will need to do is that when you basically jump on that road, you have to maintain some velocity before getting stopped. You have to run a little bit in the same direction. You must have seen that some people in the train. So like I must have observed this thing in the bus and the train itself. So when I travel to my town, so in the bus, so must have seen that there are some people basically used to sell like coconuts or drinking water bottles or some kind of you can say packets of nuts on the bus in the meanwhile. Okay, suppose that there's a toll. You must have seen there's a toll tax on the highways. So basically, when there's a when the bus is basically having some very minor velocity, they will not just suddenly jump out of the bus. Instead of that, they basically you can say run a little towards in the same direction of that bus so that they can maintain the inertia of the body, right? Instead of just getting out of the jump and fall. Okay, they do not do the same thing. I'm checking a video that I should see you. Just a moment, bacho. Able to find a single video that is explaining the same thing. Just a moment. Let me check if there is a picture. Chalo, I got one video. Okay, I'm sharing my screen to you, Bacho. So here it is. Is it visible now, Bacho? To all of you, tell me. Is this video visible to you?
Yes, sir.
Okay.
Yes,
Okay,
sir.
so there you go. So this student, this person that I'm saying you, is wants to basically jump from a moving bus. So what will happen is that this bus is moving with some velocity v, and suddenly when the body wants to move, but when the basically the your feet got stopped, so it will fall. Okay, and due to that there are more severe injuries than that. Okay, like this. Now you got it, Bachu? At least say yes or no. Is this
Yes,
clear
sir.
to all of you?
Yes, sir.
Chalo, that's good. Okay. Is my screen visible?
Yes, sir.
Check it. Okay, so this is the reason why do we like the person who is basically wants to jump out of the bus should maintain some velocity before stopping. At least should the body should have some velocity so that there is a very minor effect. Okay, just a second. Just a moment. That video is not here. Like I'm like there's no video basically jumping from the train or the bus. Okay, so is my video clear? Like just a moment, let me check. Is my screen? So it's already shared. Okay. Okay, so just wanted to show you that so that you can see this thing properly. Clear, everyone? Does anybody have any doubt so far now?
No, sir.
Sure, that's good. Okay. So this motion, this law of motion is called law of inertia. Clear, everyone? Okay, this is called law of
Yes, sir.
inertia. Okay. Okay, that's good. So basically, this law gives us the definition of force. It means that a force is a quantity which changes or tends to change the state of rest or of uniform motion. Clear? Is this clear to all of you?
Yes, sir.
Yes, sir.
Sure, that's good. Okay. Okay, let me write it here, first law of motion, because that would be very okay, because I don't want to basically make this thing a big thing. Okay. So here I'm writing here. Okay. So Newton's first law of motion gives it us definition of force. So basically in this, a force can be defined as a force is a quantity. A force is something you can say is a quantity which or tends to change the state of rest or of uniform motion. Clear, everyone?
Yes, sir.
Okay. And we will study the force in the second law. So before that, let me tell you, a force is a vector quantity. It means that it has both magnitude and direction. Clear?
Yes, sir.
This is the force. Okay. Okay. So is this clear to all of you? Please let me know last time.
Yes,
Yes,
sir.
sir. It's clear.
Yes, sir.
Sure, that's
Yes.
good. That's good. That's good. Okay, so now let's start the second law. This is all about the first law. Nothing is there. It's very like conceptual types of question will there. What will happen if you suddenly basically if the bus suddenly stops, a moving bus suddenly stops? What will happen if the bus starts suddenly? Okay, so these are the questions that will be there, and all the answers is basically a simple law called law of inertia. That if there is a change in state of the body, it will resist the change, and due to the law of inertia. Clear, everyone? Say yes or no to me.
Yes, sir.
Yes, sir.
Okay. Just to understand the force, to understand the second law of motion, we need to understand a topic. Just a moment. Just a moment. Sure. Okay. Chalo. Okay, so basically to understand the second law of motion, we need to understand a topic called momentum. Okay, first of all, I'm writing here second law of motion. So there would be two topics. So basically, momentum will be the first topic. Okay. So first of all, we'll start with the momentum. Okay, and then we'll move forward to the, you can say, second law of motion. Okay. So basically, let me tell you about what is basically a momentum. So basically, in simple word, if I say this thing, it means that momentum is the product of mass and velocity. If we talk about a simple thing, it is the product of a mass of a body and the velocity of that body. Okay. So basically, momentum is basically there. So suppose that a body is moving. So this is a ball. Let's take one example. This is a ball, cricket ball. How many of you see cricket, watch cricket? No one. Okay, chalo, koi baat nahi. So basically, you can see this thing. This is a cricket ball. So when it will basically strike by a bat, it will have a very higher velocity. Say yes or no?
Yes, sir.
Okay. So it will have a very high velocity. It means that when it will strike the body of a human, so it will produce more force. It means that it will hurt a lot. Yes or no?
Yes, sir.
Okay. Is somebody saying something? Anyone is saying something? No?
No, sir. No, sir.
I thought it was
No,
like
sir.
somebody have some. Okay. So if we talk about take a cricket ball, so what will happen is that if I basically strike the cricket ball and suddenly it strikes one of the fielder, so it means that it will hurt a lot. So momentum basically tells you about that how much motion is there in the body. It tells you about the quantity of motion in the body. It means that with what extent it is moving. Okay, it means that body moving with a higher velocity will be having higher momentum, because the momentum is denoted by P, and it is mass into velocity. Clear?
Yes, sir. Yes, sir.
Okay. So
and every moving body possesses momentum. Okay, so momentum depends on the two things. First one is mass, second thing is velocity. Clear?
Yes, sir.
Okay.
Yes.
Okay,
Yes, sir.
let me write down the definition here. Check it. And from this momentum, you can conclude the second law of motion as well. Okay. Okay. So the momentum body is defined as the product of mass, product of its mass and velocity. Here, so it will have a, it is basically, so it tells you about the quantity of a motion body does possess. Okay. It means that
Yes.
the quantity of motion in a body depends on the mass and velocity of a body. Okay. Clear? So this is the quantity. Suppose that a bus is moving. Okay, a bus is moving here, and this is a car is moving. So when the, suppose this is a person, sorry for my bad drawing, macho. Okay, so both, so let's take both the scenarios. A bus, like bus is moving, like a bus is having a mass of 2000 kg. Car is having a mass of only 200 kg. Check it. Bus is moving with a velocity 10 meter per second. Okay, and car is moving with the velocity, you can say not 10 meter per second, kilometer में ले लेते हैं. बस चलो 10 मीटर, चलो it is कितना हो जाएगा 1836 kilometer per hour. ठीक है, and if we talk about the mass, if the velocity इसकी लेते हैं हम लोग, चलो 72 ले लेते हैं. ठीक है. Now let's compare the momentum of both the, you can say, values. So what will happen is that देखो, momentum is the product of the velocity, you can say mass and velocity. Say yes or no. So if this is 2000, if I want to convert the velocity first in meter per second, it would be 2. So it is 10 meter per second coming out to be, and it is coming out to be 72 into 5 by 18. So this will cancel 4. So it is coming out to be 20 meter per second. Okay. Means that 2000 into 36, sorry, not 36, 10 is coming out to be kitna ho raha? 2010. It is 20,000 kg meter per second. This is the SI unit, I will tell you. Okay. And this is 200 into 20. It is coming out to be 400 and 4,000. 4,000 kg meter per second. Now tell me which body possesses higher momentum. Yes, bacho. Bolo. Which body possesses higher momentum? Obviously, this value is greater. 20,000 is very much greater than 4,000, almost 5 times. Right? It means that higher the mass, higher the momentum will be. That mass having the greater mass having smaller velocity will basically give more damage to the human body instead of the car having a greater speed. Okay, so the higher the mass, more momentum will be there of the body. Clear?
Yes, sir.
Okay.
Yes, sir.
So that's what the actual meaning of momentum is. It's basically understand that how much quantity of motion it is there in the body. Clear, everyone?
Yes, sir.
Okay.
Yes, sir.
So, okay, that's good. So this is what we have started. We have given you introduction of the momentum. So in the next class onwards, we will do the second law of motion and the momentum of the body. Clear? Say yes or no, please. Okay. So just allow me a second. Just give me a moment. Let me check something before leaving the class. Let me check something. Oh, so there is no assessment, bacho. Okay. So after this class, you will be having an assessment. Like in the next class, basically after this, the coming Tuesday class, you will be having an assessment of this topic, both first and second combined. Okay. So only I will be giving you assessment. Okay, bacho. So those who want to leave can leave the classes. This is all about this class. Thank you so much for joining the class and giving me your time. And I will be continuing the derivation part of the equations of motion after this class. Those who want to stay can stay here. Please let me know who is leaving, and we'll start this after this. Okay. Okay, Saad. Okay, Arham, if this this is in your syllabus, Arham. Okay, Sarah, you can also leave if you don't have this thing in the syllabus, no worries.
Okay, sir. Thank you, sir.
Welcome, dear. Bye-bye.
Sir,
Welcome. Yes.
will
Anand.
the derivation class be uploaded inside?
Anand, could you speak it again, dear?
Will this the derivation class will it be uploaded in the site?
Yes, it will be.
Okay, I'm not sure, sir. Can I ask and come?
You can ask and come. Could you please elaborate a little bit here?
I I mean, like, I'm not sure if I have the derivation part, so if I have, then I can watch it later.
Okay, ठीक है.
Thank you, sir.
Okay. Anand, just allow me a second here.
Yes, sir.
अनम आर यू देयर बच्चे?
Yes, sir.
अच्छा अनम बच्चे मैं पूछ रहा था आपके जो एग्जाम हो रहा है अभी, ये जो ये पीरियोडिक टेस्ट है ये कितने मार्क्स का है? 20 मार्क्स का?
30 marks.
30 मार्क्स। तो इसमें डेरिवेशन पोर्शन रहेगा बच्चे या फिर न्यूमेरिकल और कंसेप्चुअल पार्ट रहेगा?
सर बस acceleration तक आ रहा है, derivation अभी नहीं आएगा.
अच्छा ठीक है। तो फिर तो बेसिकली बच्चे क्या है ना, सिर्फ अभी मतलब अब ये टॉपिक 2-3 बच्चों का है। तो जैसे कि आप हो गए, हैदर है, तो कुछ बच्चे ऑफ पे चले गए ड्यू टू सम वेकेशन रीजंस, क्योंकि मिडिल ईस्ट में भी वेकेशन चल रहा है ना, अगस्त तक वेकेशन रहेगा वहाँ पे। तो इफ यू डोंट माइंड कि हम लोग इसको आगे पोस्टपोन कर सकते हैं, सो दैट सारे बच्चे एक साथ कंबाइंड होके ले लें, क्योंकि
Yes.
फिर बाद में बच्चे वो डिमांड कर सकते हैं कि सर हमें भी लाइव क्लास चाहिए, सो दैट वुड बी लिटिल बिट टाइम टू रीशेड्यूल इट।
Yes, sir.
ठीक है, अभी आपके स्कूल में पोर्शन नहीं है तो वी कैन जस्ट राइट नाउ होल्ड इट फॉर अ व्हाइल।